What's up, everyone? My name is Dr. Chris Hacks, and today we have the next episode in our CryptoPals Crypto Challenge. Today we're going to be looking at AES in ECB mode. Okay, now real quick, do have a little caveat. I did film this video once already, but I didn't have audio enabled, so today I'm not going to be coding, but we will go through the code line by line, and I'll explain everything that's going on. So I won't be typing anything, but we will still get that explanation, so it should still be good. But let's jump to this challenge. First off, what is AES and what is ECB mode? So AES is the Advanced Encryption Standard, and ECB mode is Electronic Codebook. So basically what this is, it is a encryption algorithm that takes the data and uses a key to encrypt it against a codebook or a table of values. It's not really the best way of doing things, which is why we're going to be breaking it later. However, first, for this challenge, we need to actually implement the functions. So, this file is base64 encoded and has been encrypted with AES 128 in ECB mode. This is the key, and all we have to do is decrypt it. So, we're just going to implement the function. So let's jump into our code. Alright, so first off, I already have the challenge7.cpp file already. The first thing I did was I made a new header called AES.h. And here we're going to have our encrypt and decrypt functions, and then we're also going to have this library for OpenSSL-EVP. If you are following along with Visual Studio, you will have to use the VCPKG package manager. You have to use a package manager to include this. I don't remember the acronym, but it does take a little bit of time to set up. I already went through and set it up myself, but if you guys want a video on how to set this up, let me know and I will make that. Okay, so we get the package manager set up, and then we can start making these functions. Next, we have the AES.cpp file, and we have the encrypt and decrypt functions. So, let's just go over what they do real quick. We'll start with encrypt. So the first thing that we need is the key has to be a size of 16. If it's not 16 bytes, then it won't work. That's what this encryption standard requires. Later on, we might use something like 192. I don't believe it's part of the CryptoPals challenge, but that does exist. There is the 192, and there's a couple other block sizes you can use. A couple other standards. There are different key sizes for different standards, so it just depends. But for this one, the key size is 16 bytes. So the first thing we do is we're going to check our key size. Then we need to create this object, the EVP cipher CTX. This is the context. This is going to be the object that actually does everything for us. Now, you may notice I did choose to start throwing errors. The reason why I'm throwing errors is just so that if something does go wrong, we will be able to see that something went wrong and troubleshoot it a little bit easier. I'm not a big fan of throwing errors in C++ code because it can crash the program and you should be able to handle stuff gracefully. That's why I like returning strings and whatnot. But for this, because we are using it and we're not shipping this code, I'll throw errors. Alright, next up, we're going to actually initialize our object. So we call this EVP encrypt initialize underscore EX. We want to make sure it returns a value of 1 so that we know it was successful. And we're going to be passing in this context object. We're going to be passing in this AES 128 ECB thing, this EVP cipher that our library provides. Pass in a null pointer, and then we have to actually reinterpret cast our key. We have to take the data from it, and that's a string right now. So we have to reinterpret cast to a constant unsigned char pointer because that's what it wants, which is fine. We can do that. So that's what we do here. If this succeeds, then we can move on to the next step, where we actually get our ciphertext. We're going to resize our ciphertext to the correct size, so it's going to be the original data size, plus there's a little constant here that our library provides, the EVP underscore cipher underscore block size. This will size our string correctly, so that we have a ciphertext string that is the correct size, so it makes it a little bit more efficient later on. So we'll do that. And then what we're going to do is we're actually going to encrypt it. So we go through and we pass everything into a EVP encryption update function. We pass in our context, a reinterpreted cast. So we have another unsigned char pointer, which is our ciphertext. We're passing in a reference to the very first character so that the library knows it's due. We pass in a variable for the length so that it actually passes in, it gives us back the actual length of our ciphertext. we pass in our plain text data here, and we pass in the data size. That way the library knows how much data it's working with and where to put the data once it's encrypted. If this all works, it will return a value of 1. If it doesn't, then we will free our object and then throw another error here. But if it all works perfectly fine, then we will move on to the next step. Next up, we have our EVP encrypt final. Basically, what this is doing is it's finishing everything up. It's making sure our ciphertext is the correct length. Every single ciphertext will be, a certain length will be padded a little bit. So this is what it does at the end. It will actually finally make sure everything is the correct length and good to go. And then finally, after that, we have our ciphertext length, which we'll use to resize our ciphertext in a minute. And we also need to free our object. We free the CTX, the context object, just because we have to have that good memory management. So we do all that, and then we get our encrypted ciphertext. For the decrypt function, it is identical. You can literally just copy and paste the encrypt function into the decrypt function body. The only difference is instead of calling EVP encrypt, you're going to call EVP decrypt. So very, very simple, very, very easy. So the same stuff. All of this code's on GitHub, so it's very easy to find if you guys had trouble following along if I went too quickly. I'll just scroll through this real quick so you guys can pause the video at any moment, copy this stuff down. Also, this is using an external library. We can actually do this ourselves. We can write the code for it. There is a NIST paper that details the exact process, and if y'all want to see me go through it, I can make another series actually implementing AES 128 ECB by hand. It is a little bit trickier. It'll probably take 2 or 3 videos to get through the entire thing, but we can definitely do it. You guys just have to request in the comments, and then I will go ahead and make that video. But for now, we're just going to make things simple, and for the context of this problem, we'll use the library. So, once everything's implemented, we can go back to our challenge 7, and it's pretty straightforward. All we're doing is we're using our key here, yellow submarine. We will open up the file, which is 7.txt, read it to a buffer, and then using that buffer to string, we'll base64 decode it, and then store it in the string data here. Pass data into our decrypt function, and that's all there is to it. And that's how we decrypt it. And these functions will be used later. So let me just go ahead and show you it works. Here is our base64 garbled text. If you were to base64 decode this and output it, it's a bunch of random symbols, a bunch of random ASCII characters. So what we can do is I can actually run this here, and we'll see that it will code everything correctly. Give it a second to compile, and here we are. Yep, it went through and decoded our file correctly. So, if you guys want to check out the code yourself, it is on the GitHub. I will link that in the description below. Also, if you guys do want a video either going through the AES encryption or going through the setup for the package manager, let me know and I will make those. But thank you all for watching. Sorry for the shorter form. I did mention that I coded everything and then I didn't have audio, so that was my mistake. I won't have that in the next few videos, but thank you all for watching, and I will see y'all in the next video.